Hello everyone. So you guys might have heard about Llama and ChatGPT. The capability that the model holds is because it is trained little different. The model are trained by reinforcement learning with a twist. Here we use human in the loop to train the model. So today we are going to see how this model are trained and why this training method is so powerful to get a better result. I have divided this video into sections. One is theory, where we'll understand everything about reinforcement learning with human feedback and how this model trained. Also, we'll see its implementation. So, let's get started. First, with the theory. To train the models with reinforcement learning with human feedback, there are three steps. The steps are create a policy models, create a reward models, and create a model with PPO. In the step 1, we create a policy model. The policy model are basically the model which does the tasks. The tasks can be according to your need. Like for the summarization, policy model summarize the text. So here we fine tune a model to do a task. So let's take the example of the summarization. We pass the model with a text and the model generates a text 1 and text 2. This is the step where we need human. The output generated by our model is evaluated by the human in the loop. As you can see here, the model can be trained to generate two outputs like output 1 and output 2 by using a different decoding method. Or you can use two models in this case, one which perform better and one which perform worse. And these output are evaluated by the human to create a dataset for our next model, i.e. reward models. Here's the one trick that you can remove human, because evaluation by the human is time consuming and not everyone can hire a evaluator to evaluate the model output. That I will say you at the end, so please bear with me. Then in the second step, we train our reward model. In the first step, we use a human which evaluate the output generated by our model. The model here we use is policy model, which generates the output for our reward models. The main objective of training a reward model is to remove the human for future process. The reward model is trained on such a way that it identifies whether the output generated by the model is good or bad. So to train it, we have a dataset PPT step 1 where human identified a good and bad output. So we pass a good and bad output to our reward model. The reward model created a reward named as RI and RK. We just calculated loss by using a logistic regression loss and trained our reward model. In this diagram, you can see there are two reward models, but this is the one reward model where you can pass one input to a reward models along with others at the same time to calculate the loss and train our model. In this way, the reward model can identify if the given text is better or not, or you can understand it as it can give a score to our summarized result, therefore removing the human in the loop. So in the third step, we combine step 1 that we created a policy model and step 2 as a reward model to train a final model. That is, we need to train our policy model with PPO. So let's understand it with the summarization tasks that we have talked earlier. So our task is to summarize the text. We pass the text to a policy model. The policy model in the step 1, we have trained it to generate a summarized result from the above text. It will generate a summarized result. The summarized result is then passed to a reward function which calculates the score for the generated text and give us a score for our output. In that way, we can identify if the output is good or bad, and We'll update our loss accordingly to make model generate better result. Here we use kernel divergence loss to obtain a better result. The kernel divergence loss is or have the formula as this. Here Rxy is a reward function that we can get from the reward model as R defined here, and we'll give a kernel divergence to it, as in the reinforcement learning training there is a much variation in a loss, and this is like a regularization to our loss function. So this all for the theory. Hope you get it. Let's move to the code. In the code section, we'll be using the TRL library as of now, but most of the code we will self-write. We need Hugging Face to load the models and TRL for our training, and PyTorch, Pandas and NumPy as our helpers. If you haven't installed it, just pip install TRL, Pandas, NumPy and Transformer. So let's import all the necessary libraries, as import NumPys, Torch and Pandas. We need auto model for casual LM to train to load our model, and auto tokenizer to load our tokenizer. The trainer to train, as we will not create a full pipeline for the model training, and it will be handled by the Hugging Face and with the trainer argument. In the second step, let's define some parameter that we need later while training and are constant, as learning rate will set it to 1e to the power 5 with a batch size of 16, and to save our model we need an output directory. We'll name it as supervise summarize checkpoint, as the task we are doing is summarization, and with the number of the training step box as 20 and max length of 550. You can change it accordingly as you want. So the first step is creating a policy model for human evaluation. Here, as discussed earlier, we'll fine-tune a model to do a particular task to get a better result. For your custom dataset, you can first adapt your model and fine-tune it to get a better result. To learn more about the adapt, you can check my previous video. So, for a policy model, we'll be using a dataset from Carper AI as summarized TLDR. It contains a prompt which is a Reddit post and is summarization as a label to it. You can use any dataset if you like. Just download like. So in the following example, we'll be using this dataset while moving forward. So you can download it from this Hugging Face repo, and in the datas folder you can just download test, train and valid. In this section, for a smooth transition or for the faster training, we'll be using test as of now. After downloading, you can just read it with a pandas, as panda does its parquet, as data is in parquet format. Now to train a model, we need a data loader. In a data loader, we pass as an initial argument as training path, tokenizer, split to identify it is as train or test split with a max length of 256. The max length I have changed it to 256 because you can test it in a Colab as well. So in this class, we'll just define a post list to store our post and labels to store our labels. We'll just iterate over the pandas data frame and append a prompt or a label to it and define a sample parameters. Thus, we create a donder, a get item in the class as this, which act as a generator for our data loader. We tokenize our prompt from self-tokenizer while passing the max length to 256 and padding to the max length and truncate the output if needed, along with the labels as encoding dict label. The tokenizer returns the input labels and attention marks that will we pack all together and return as dictionary for our data loader. In the next step, let's define a tokenizer and model for our training purpose for a policy model. Now, in this case, I'll be using tiny star coder for our testing. You can use any model as you want, including Falcon or Llama or even ChatGPT or GPT. Here, I have used star coder as my end goal was to experiment a prompt to the code using reinforcement learning with human feedback. Now, if you want to use other model, just go in Hugging Face and search any model you like. Like if you want to use Llama in this model, you can just search in the model and search for the Meta LLAMA-2 7 billion parameter and just copy the text from here and you can just replace this with llama bit as this. But if you want to experiment with Google Colab for a code given, you can use TinyStack Coder as of now. Now we create a train object from our data loader. We'll use it for train dataset and you can use for the validation dataset as well if you want. Now to check the data loader, we can just print its input IDs and label to ensure that our data loader is performing well. You can see the output as input IDs and label as follow. Here in the tokenizer, the padding is set to right. You can use it in the beginning by stating padding as a left while defining a tokenizer. Now for the training purpose, we'll not create a whole pipeline by our one. So to make our thing easy, the Hugging Face provide a trainer that handles every pipeline for us. We'll define our training argument for training the model. In the training argument, we'll define the output directory to store our model after training with learning rate, batch size, and epochs. For now, we'll set it to the 2 and logging steps as a 10 to see the output of our model or loss of our model every 10 step. Then later we'll just define a trainer where we pass a model, the train dataset, and the training argument that we have defined earlier. And we'll just call trainer that train to start training our model. So after training for the 2 epochs, I have received the loss as 0.941 and that's pretty good. Then we save our model to a different directory. You can use the same directory that we have defined earlier as well. Now to check how good your model is performing, you can just load your model from auto model from casual LM dot from pretend and provide a directory that you have saved your model on. and similar goes for tokenizer that we have did earlier, and pass the tokenizer and use model.generate to generate a summarized result. We then decode our summarized result with tokenizer the decode to get an output for the token generated by model.generate. So that's all for the part 1. As the video is becoming longer, so let's see reward and PPO model in the next video. As I have told you in the beginning how to remove the human in the step 1. So let's go into it. In the step 1 we have the human. So instead of using a human, we can use a powerful model which we consider as a human to determine output from our policy model. In that case, we can use ChatGPT's or OpenAI's any model in that case and use ChatGPT's summarize output as good and bad. This is how you can tune a model to behave like ChatGPT or generate an answer like ChatGPT. We can use ChatGPT to create a ChatGPT. After the step 1, the dataset that we will be preparing is something like this. Here, the prompt is a text, and this is where the human has done the work. The two output you have seen here as output 1 and output 2 are this that the model have generated, and human is the one which identifies if A is good or bad. So we'll choose A as a summarize for the prompt here and reject an other model. So instead of using the human, we can always choose our output generated by our powerful model in this case that we have discussed here, as the powerful model can be ChatGPT. So what I mean to say is, instead of creating a two output for the model, we can ask the policy model to create an one output for our text provided and create an different output as output B from an ChatGPT for the text provided. And in that case, we will not need a human. We can always use the output generated by the ChatGPT to be chosen and other as a rejected. So this dataset will be using in the reward function as a next step and the next video. So that's all for this video. Hope you like this video and like, share, and if you have any suggestion or question, feel free to comment. I will love to help. Thank you and happy learning.